Today you're about to discover why the sky is blue. Not the explanation humans usually give each other, but the real scientific answer. As it turns out, this wasn't an easy mystery. Some of the greatest human thinkers who ever lived tried to solve it and failed. Even Isaac Newton came close, but he still didn't have the complete answer. It took humanity more than 2,000 years to finally uncover what was really happening above your heads every single day. The investigation begins with a surprisingly simple question. What exactly is light? At first glance, sunlight looks completely white, plain, simple, almost colorless. But pass that same sunlight through a glass prism, and suddenly a rainbow appears. The prism isn't creating those colors. It's revealing the colors that were already hiding inside white light. That's our first clue. Sunlight isn't one color. It's every visible color traveling together. Those colors differ in just one important way. Their wavelengths. Red light has long waves. Blue and violet light have much shorter ones. Now let's move closer to Earth, because this is where the mystery finally starts making sense. Humans often forget that they're standing at the bottom of an enormous ocean. Not an ocean of water, an ocean of air. That atmosphere is packed with tiny nitrogen and oxygen molecules floating all around you. And here's the detail that changes everything. Those molecules are incredibly small. Much smaller than a wavelength of visible light. For centuries, nobody understood what happens when light meets something this tiny. Then John Tyndall and Lord Rayleigh finally solved the puzzle. They discovered that light gets scattered. As sunlight enters Earth's atmosphere, it doesn't simply travel straight through. Part of it begins interacting with those tiny gas molecules. Imagine a huge ocean wave rolling past a tiny buoy. The wave barely notices it's there. Now imagine a much smaller ripple striking that same buoy. Suddenly, the water splashes in every direction. Blue light behaves much like that smaller ripple. Its short wavelength makes it scatter far more easily. Red light, with its longer wavelength, mostly continues straight ahead. Blue light keeps bouncing from one tiny molecule to another, scattering again and again across the atmosphere. Rayleigh even calculated the difference. Blue light scatters more than 5 times as strongly as red light. Eventually, scattered blue light reaches your eyes from every direction. That's why the entire sky appears blue. Not just the area around the sun. What you're really seeing is trillions of tiny scattering events happening every second above your head. But our investigation uncovered another mystery. Violet light has an even shorter wavelength than blue. It should scatter even more. So why doesn't the sky look violet? First, the sun naturally produces less violet light than blue light. Second, part of that violet light gets absorbed high in Earth's atmosphere. The final reason isn't in the sky at all. It's inside your eyes. Human vision relies on 3 different types of cone cells, each sensitive to different parts of the visible spectrum. When blue and violet light arrive together, your brain blends those signals instead of separating them. The result is the familiar color you call sky blue. A creature with different eyes might see your daytime sky as an entirely different color. Now let's explain one more beautiful phenomenon. At midday, sunlight passes through only a relatively thin layer of atmosphere, producing the familiar blue sky. At sunset, sunlight travels through a much thicker layer of air before reaching you. Along that longer journey, most of the blue light has already been scattered away. What remains is mostly red, orange, and yellow light, creating the spectacular colors of sunset. Dust, smoke, and volcanic ash can make those sunsets even more dramatic by changing how light scatters. Need proof? Look at the moon. With almost no atmosphere, its daytime sky stays completely black. Mars tells a different story. Its dusty atmosphere creates an orange daytime sky and a blue sunset. Same physics, different atmosphere. Case closed. The sky isn't blue because it's painted that way or because it reflects the ocean. It's sunlight, invisible air molecules, and the remarkable way your own eyes interpret scattered light. Humans finally solved the mystery. We just documented it.